This lesson is about fundamental dimensions. What are fundamental dimensions? Well, we have three of them: mass, length, and time. And we use the capital letters M, L, and T to indicate these dimensions. What makes mass, length, and time fundamental? Well, no other dimensions make up these fundamental ones. In fact, we use these fundamental dimensions to create other units. You will learn about combined units in another lesson. You may have noticed that I used both dimensions and units on the previous slide. So what is the difference between dimensions and units? Sometimes there is no difference that we intend, which means dimensions and units are often used interchangeably. However, other times we do want to make a distinction, and that is the purpose of this slide. For dimensions, the dimension is the physical quantity itself, for example, mass. Units, on the other hand, is the number we assign to the physical quantity in order to measure it, for example, kilograms for mass. So what are the fundamental units that are typically used? Examples of each type include, for mass, we have kilograms, grams, slug, pound mass, and so on. For length, we have meters, centimeters, inches, feet, and so on. Likewise for time, seconds, hours, nanoseconds, days are all acceptable units of time. Again, remember, for dimensions, mass is mass, length is length, and time is time. However, for units, there's a different story, meaning we can convert between different unit systems, which is important. In fact, you will learn about converting between unit systems in another lesson. The international system of units is the most commonly used in engineering education. Other unit systems are used in industry, but again, the SI unit system is most common in engineering education. You will learn more about the SI unit system in another lesson. Here, we just want to indicate what are the fundamental units in the SI system. For mass, we have the kilogram, given the symbol kg. For length, we have the meter, given the symbol lowercase m. And for time, we use seconds with lowercase s as the symbol. These are the default units that we use to create other units in the SI system. This is opposed to using something like grams and centimeters as the default units. Let's get to our example problem. Non-dimensional parameters are important in many engineering problems. They combine physical parameters in such a way that the fundamental units or dimensions cancel. Therefore, a non-dimensional parameter has a dimension of 1. An example is the Reynolds number found in fluid mechanics. The Reynolds number, given the symbol Re, is defined as rho, the fluid density, times u, the fluid velocity, times L, a length scale, divided by mu, the fluid viscosity. In the SI system, units of density are kilograms per meter cubed, and units of velocity are meters per second. In this problem, we are asked to find what are these units in terms of fundamental dimensions. We use square brackets to indicate the units or dimensions of a particular quantity. For example, the units of the density are kilograms per meter cubed. And therefore, we will write a square bracket around the symbol rho for density and equate that to kilograms per meter cubed. We recognize kg and m as the units for the dimensions of mass and length. And therefore, we can write the dimensions of the density by again writing rho in square brackets, which we know to be kilograms per meter cubed, and substituting for mass per length cubed. Length cubed is volume, so you might recognize the density as mass per unit volume. Similarly, the velocity has units of meters per second, and we can write u in square brackets and equate that to meters per second, and then substitute for length per time. For the homework problem, we will extend the example problem. Dimensional analysis is another helpful tool. It can be used to uncover information about a parameter you might not know. Recall the Reynolds number from the example problem. RE equals rho, the fluid density, times U, the fluid velocity, times L, a length scale, divided by mu, the fluid viscosity. Previously, we didn't say anything about the viscosity. So, knowing the units of rho, U, and L, and the fact that the Reynolds number is dimensionless, we can then find the units and dimensions of viscosity. And that is the purpose of this homework problem.